Ever wonder why some AI models stumble over complex problems, even when they're given step-by-step examples? It's like watching a beginner cook follow a recipe. Everything looks perfect until they add the wrong ingredient. Today, we're unraveling a surprising twist in AI reasoning, why longer thinking can actually make small models worse, and how researchers are fixing it. Let's start with the basics. Chain of thought, or CoT, is the AI version of a student writing out their math steps. Instead of just saying the answer is 42, the model explains, first I add 10 and 15 to get 25, then I multiply by 2, and so on. This works wonders for big models like GPT-4, but what happens when we try this with smaller models, like ones that power your phone or smart speaker? Our research uncovered a big problem: long CoT degradation. Imagine training a small model on thousands of detailed reasoning examples. At first it seems to learn, its answers get longer. But here's the catch: the longer the response, the more likely it is to make mistakes. And when those errors pile up, the model's performance plummets. In experiments, models like Qwen, LLaMA, and Gemma started losing up to 75% of their accuracy after just 8,000 examples. Even 220,000 examples didn't always fix the problem. It's like giving a student a textbook full of complex problems but no way to check their work. Their confidence grows, but so do the errors. So why does this happen? Our analysis points to error accumulation. Longer reasoning chains mean more steps, and each step is a chance for the model to go off track. Small models with limited capacity can't handle this complexity as well as their larger counterparts. It's like asking a beginner pianist to play a symphony. They might hit all the right notes, but the overall melody falls apart. But there's hope. We found that sufficiently scaled training can mitigate this. When small models get enough high-quality CoT examples, they recover and even outperform their initial results. The key is balance. Too little data and the model falters, too much and the errors multiply. This matters because small models are everywhere: on phones, in edge devices, and in applications where speed and efficiency are critical. Understanding their limits helps us build smarter, more reliable AI. Let's test this with a real example. Consider this arithmetic problem: 14 times 21 times 38 plus 32 plus 23 plus 31 plus 3, 11 plus 59 plus 71 plus 60. Sounds tricky, right? But even smart models can trip up if they mix up the steps. First, the expression has parentheses, which means we need to calculate what's inside them first. That part is 14 times 21 times 38, plus some numbers. Let's break it down. 14 times 21 is 294, and 294 times 38. 294 times 30 is 8,820, and 294 times 8 is 2,352. Adding those gives 11,172. Then we add the numbers inside the parentheses. 32 plus 23 plus 31 plus 3 equals 89. So the total inside the parentheses is 11,172, plus 89 equals 11,261. Now here is where things get tricky. The model in the study tried different approaches. One method: it added the numbers outside the parentheses first, like 32 plus 23 plus 31 plus 3, 11 plus 59 plus 71 plus 60. But wait, that's a big mistake. According to math rules, you have to finish the multiplication inside the parentheses before handling the rest. Adding those numbers first breaks the order of operations, like mixing up the steps in a recipe. Let's fix that. Starting with the correct total inside the parentheses, 11,261, we subtract 11, giving 11,250. Then we add 59, 71, and 60. Step by step, and the final answer is 11,340. But here's what's fascinating. This study shows how AI learns to think through problems. Researchers tested models with different amounts of training data. Think of it as a library of problem-solving examples. The more data a model had, the longer its responses and the better its accuracy. For instance, bigger models like Qwen 5-14b crushed tough math challenges, while smaller ones struggled. But there's a secret weapon: reflection. Models like Qwen 5-3b didn't just spit out answers, they broke down steps, checked their work, and even caught mistakes. Imagine a study buddy who double-checks your math. The data showed that balance matters. Too little data and models guess. Too much and responses get wordy. The sweet spot: models like LLaMA 318b and Qwen 5-7b delivered precision without the fluff. So what does this mean for AI? It's not just about size, it's about how models learn. Quality data and structured thinking could make AI not just smart, but reliable, whether solving equations or navigating real-world challenges. Next time you see an AI answer a question, remember, it's not just memorizing facts. It's learning to think, step by step, like a student with a notebook. And for small models, the path to better reasoning isn't just about giving them more steps, it's about giving them the right ones. Thanks for watching. If you want to explore the full study, check the links in the description. Stay curious, and we'll see you next time.